In this example, we're going to take a look at an inner product on the set of 2 by 2 matrices, where the inner product of two 2 by 2 matrices is simply going to be multiplying the corresponding entries together and then adding them all together. Here we're going to define two matrices as A being 5, 1, negative 3, 4, and the matrix B being 2, 3, 3, 4. We're going to find a couple things using this inner product. First thing I'd like to do is find the distance between matrix A and matrix B. Now the definition of the distance between two vectors is that this is the magnitude of A minus B. Could also technically be the magnitude of B minus A. Turns out those two things are going to be equal to one another. So we'll set this up as matrix A minus matrix B. So that'll be 5 minus 2 for the first component, the 1, 1 entry, 1 minus 3 for the 1, 2 entry, negative 3 minus 3 for the 2, 1 entry, and 4 minus 4 for the 2, 2 entry. Next up, we'll be taking the corresponding components and multiplying them together, and by that I mean we'll be multiplying 3 times 3. We'll be multiplying negative 2 times negative 2. We'll be multiplying negative 6 times negative 6. And we'll be multiplying 0 times 0. Adding them all, and then taking a square root. This will be 9 plus 4 plus 36 plus 0 for the square root of 49. Square root of 49 simplifies really nicely into just 7. Next up, on the subject of things that require two vectors, let's also find the angle between the matrices. Now, the definition of the angle between two matrices is that this will be the cosine of theta is equal to the inner product of A with B divided by magnitude of A times the magnitude of B. Let's start with the inner product of A with B. Now again, according to the definition at the top of the page, we will be multiplying corresponding components together and adding them all up. So, multiplying 5 times 2 for the 1, 1 entries. For the 1, 2 entries, we'll do 1 times 3. For the 2, 1 entries, negative 3 times 3. And then for the 2, 2 entries, we'll see 4 times 4. So I'm seeing 10 plus 3 minus 9 plus 16. 16 minus 9 is 7, plus 3 is 10, plus another 10 is going to be 20. Next up, for the magnitudes of these vectors, or matrices as it were, this will be basically our standard operating procedure. We'll take each of the entries of A, square them, and add them together. So 5 squared, 1 squared, negative 3 squared, and 4 squared. Adding all of these up will give us 25, 26, 35, I believe that'll be the square root of 51. For the magnitude of B, it's going to be equal to the square root of, we'll do the same thing, 2 squared plus 3 squared plus 3 squared plus 4 squared for those 4 entries. So that'll be, 18 for these two, 20 for these two. That'll be a total of 38. So as such, when we set up our cosine of the angle is going to be the inner product of the two matrices, 20, divided by the product of their magnitudes. So as far as figuring out a final answer for this one, if we wanted to approximate this, this would be theta is equal to the arc cosine of 20 divided by the square root of 51 times the square root of 38. I can tell you it's going to be an acute angle, but that's about all I can tell you at this point. So heading into the calculator, we'll ask for the arc cosine of 20 divided by, extra set of parentheses, square root of 51 times the square root of 38. So rounding up the second decimal place, it's looking like we have about 62.98 degrees for an approximate angle between these two matrices using this inner product on the set of 2 by 2 matrices.